Welcome back to FIREX Tech Talks this morning. Next up, we'll be hearing from Rottguard, which manufactures direct-acting low-pressure, or DLP, fire suppression systems using heat-sensitive pneumatic tubes for the protection of unoccupied spaces. DLP systems are said to offer round-the-clock protection from the devastating consequences of fire and have been tested to LPS 1666 and internationally recognised test fires. DLP systems extinguish fires automatically, leaving no residue. Rottguard will explain how in the video in just a moment. And what's more, the Rottguard team will be joining me live for a live Q&A straight after the film. Join the live Q&A session from the agenda or on the link below after this video.
Hello, my name is Gerald Glenihan, Managing Director of Rottguard Fire Systems, and today I'd like to introduce you to a range of fire protection systems that we design, install, commission and manufacture. Rottguard DLP systems are principally designed for the protection of small, defined, unoccupiable enclosures as defined by LPS 166 standard. The tube is attached neatly to the underside of the trunking across over each of the pieces of switchgear, and it's terminated down here at the end. This represents here where a cable has gone on fire, and the heat from that fire was sufficient to rupture the tube here. It would have extinguished the fire instantly and left no residue and would have had no impact on anyone within the room. We're showing here how the cylinders can be mounted vertically or horizontally. Once the tubing has been installed and pressure tested, the ball valve here is opened and that releases the liquefied agent through the tube. The pressure switch is normally open when the cylinder is pressurized, and on activation of the system, this pressure switch can signal to a fire alarm system, either be it a conventional one or an addressable one's IO unit. The systems have been installed in over 20 countries across 5 continents. This is a representation here of a Rottguard DLP system in the manner in which it could be used to protect an electrical distribution board, showing all the MCBs here and the circuit breakers below. We've already seen how Rottguard DLP systems can protect electrical enclosures. This is an example of where the same system is used to protect a fume hood. In this instance, the fume hood is quite small. They're normally somewhat bigger, and hence we have shown this system with a bigger cylinder. It has the capacity of extinguishing the fire locally. It will leave no residue and have no impact on any personnel working in the area. The tube will again rupture in the same way as we'd seen in the electrical application. This is an example of a Rottguard DLP system in the manner in which it would protect a motor control cabinet. If we look at the inside, you'll see all the various switchgear components. We have contactors, circuit breakers, a transformer, all the rail terminals and relays. We're using a small cylinder in this instance to protect this enclosure. This here is representative of a wet chemical system used for the protection of commercial kitchens. Rottguard are the Irish agents for this Le Havre system. It is UL listed and it is certified by the Loss Prevention Council Board. It's a very good system compared to others in that it is spring loaded, it requires no cartridge which means less maintenance. All the nozzles are color coded so that any fire officer or insurance agent can look at it and determine from a checklist as to whether the system has been designed properly, whether all the nozzles are in the right position and at the right height. The wet chemical extinguishes fire by cooling, and it creates a soap-like froth referred to as saponification on top of the burning oil in something like a deep fat fryer. Again, we rely on photographs, if not a drawing supplied of the actual kitchen, and we determine how many cylinders, the size of the cylinders, which come in different sizes, and we produce a design drawing like this showing the different color-coded nozzles and where they should be. And also they have a feature with them that this safety pin here used to arm the system in the first instance has to be removed before this cover can be put back on. So you couldn't have a situation where somebody servicing the system inadvertently fails to refit a gas cartridge used to discharge the agent out through the discharge pipe here and nozzles as is seen here. We have supplied several of these systems for use in hotels, fast food, in restaurants and canteens, in factories and schools, and we think it's a very good system compared to others. This here is a representation of a dry powder system for the protection of vehicles. There are two different systems. One is American, the other one is by Le Havre. They market it as a bus shield system, principally for the protection of engine bays on buses. This other one here, it can have many cylinders and be used to protect a larger risk. They can be activated manually or they can be activated automatically by means of this linear heat detection cable, which will trigger an alarm on the control panel. This larger cylinder here, which is a 25-pound cylinder, that could be triggered by this point heat detector, which come at different temperature settings. There are examples here of systems that we installed for Liebherr in the images behind us. This one here is a generator enclosure on one of their rubber tire gantry cranes. This is a representation of a clean agent fire suppression system commonly used to protect the whole of an electrical room, server rooms, comms rooms, archives, and so on and so forth. They use one of two agents, either FM200 or Novec, both of which are the most commonly used agents to protect such risks. In the event of one of the smoke detectors picking up smoke in the room, it will activate this bell. Only if a second detector goes off will it trigger a second stage sounder, which oftentimes has a strobe light incorporated into it. 30 seconds generally after the second stage sounder is activated, this panel will send a signal to this solenoid to energize, thereby opening the valve on the cylinder, and the gas is discharged out through the discharge pipe. These systems commonly are designed to have 7% concentration in the protected room in the event of a discharge. To ensure that the room has the capacity to retain the extinguishing agent at the design concentration, it's necessary to do an integrity test on the room. CO2 is used in areas that can't be totally enclosed, and they're commonly used in ships' engine rooms because the CO2 is less expensive than any of the clean agents associated with these. This is a mock-up of a system used to protect 4 cat generators in one of Al Marai's factories in Saudi Arabia. It's represented down here, small scale photographs. This is one of 27 cylinders that were employed in that system. This is the electronic control panel used to control the detectors. This system is UL listed. The liquefied CO2 in this instance is stored at approximately 850 psi. It doesn't have any pressure gauge on it compared to the other system because the pressure of the CO2 within the cylinder will fluctuate with temperature throughout the day. The pilot control panel operates pneumatically in that this regulates the pressure down to 100 psi. That pressure is used to control a pneumatic timer in this instance, which can be set generally again to 30 seconds. You can see in this instance here that the pipe work associated with this system is Schedule 80 pipe, which is of a higher pressure rating, and these are 3,000 pound fittings as compared to the Schedule 40 pipe for this system, where the pressure rating is significantly lower. If you are interested in a Rottguard DLP system, you should contact us. Provide us with any drawing or dimensions of the cabinets you would like to protect, or indeed send us photographs, and we can prepare drawings which we will send to you in PDF form. Welcome to our next FIREX Tech Talk, where I'm delighted to be joined by Gerard from Rottguard, with people still joining. So we'll just while people are still joining, Gerard, thank you very much indeed for joining us. Tell us very quickly, for anyone who missed the video, maybe joined the video a little bit late, or is so enthusiastic about chatting to you they've come straight to the Q&A. In a nutshell, tell me a little bit more about your fire suppression system that you were showcasing in the film just now. I'm showing a number of fire suppression systems, all of which are mounted on the wall here behind me. They range from wet chemical systems, a CO2 system, a dry powder here protecting a generator. There's a DLP system here protecting a fume hood. We'll go around again, and you will see a wet chemical system here for the protection of a kitchen. If I keep going here, you will see the inside of a server cabinet protected by a DLP system. And if I keep going around, we'll come back here to a clean agent system with FM200. And in the corner here, you will see a total flooding CO2 system with a door blower machine for carrying out integrity tests. So we cover a range of fire suppression systems, but we manufacture a DLP system, which is principally for the protection of small, defined, unoccupied enclosures. Most commonly, we protect electrical cabinets, server cabinets, comms cabinets, fume cupboards, and we've also protected CNC machines with this system. We are working on indirect application systems at the moment and hope to have them independently tested next year, but they all come under various standards governing such systems for clean agents, powder, wet chemical, etc.
Well, Gerard, first of all, thank you so much for taking our session today in a room where we can see so much of the technology demoed right behind you. I'm pleased to say that your fire suppression systems have ignited quite the number of questions on our platform here. I'm going to dive straight into those. How many schools have you provided this? Well, have you provided this system to schools? How many? Just out of interest, I can't see the full name there, but thank you very much indeed for your question. Yeah, so your systems in schools. Tell us more.
Yes, I have installed many wet chemical systems in school canteens for the protection of their kitchens. DLP systems, they're not used very commonly in schools. They're mainly used for the protection of small unoccupied enclosures in industrial applications, in server rooms and in comms rooms. In schools, they might tend to have one main switchboard, and quite often they don't have the budget or the inclination to protect their switch rooms with these DLP systems,
right.
Which are more cost effective than trying to protect the whole room with a total flooding clean agent system, for example.
Super, thank you very much. Another question here. What is the agent used for protecting fume hoods? Is it compatible with the use of oxidizing chemicals in fume hoods like, sorry, excuse me, I didn't major in chemistry, perchloric acid?
Yes, we use one of two agents commonly known by their manufacturer's trade names as FM200 or Novec 1230. And both of those agents, when they discharge, they don't leave any residue, and they're suitable for Class A, B, and electrical fires. And so in that respect, they would be suitable for protecting a fume hood. And you can partially see one there behind me where the tube is installed around the sidewall. You can't see it on the roof of the fume hood, but fume hoods are an ideal application for these systems because they fall inside the criteria as set out by LPS 1666 for what can actually be protected with such systems, which is essentially, in broad terms, an area 2 cubic meters in capacity. But the standard also makes provision for protecting up to 4 2 cubic meter enclosures using a maximum of 40 meters of tube. But the tube can only be installed in 4 by 10 meter lengths of tube. This is to ensure that the tube isn't too long and that the pressure drop won't adversely affect the time it takes for the agent to discharge.
Super. Thank you very much. I hope that was helpful to your question. The question here, is CO2 still permitted, or is it specific processes? Is it for specific processes or applications?
Yes, it is still used. There's one here behind me, which is essentially a mock-up of a system that we commissioned in Saudi Arabia. It was a fully automatic fire suppression system. I inquired about it at the time from a supplier in the UK, and I was told that you would need planning permission in the UK to install such a system. But in places like Saudi Arabia and other countries, such systems are commonly installed. I suppose it's very much a question of horses for courses. If somebody goes onto my website at rottguard.ie, there is actually a page on CO2 systems, and it shows in that instance a generator room with 4 cat generators protected by this CO2 system. Now, that particular system had the capacity to reduce the oxygen level in the room within 50 seconds to a level that wouldn't sustain life.
Wow.
But they're not like a clean agent system when designed and installed properly, in that apart from the electronic controls and the time delay, with such a system, there are pneumatic controls as well that can be seen here. There's a pilot control cabinet there, low down on the wall. And what that does essentially is, as the system is about to discharge, it takes some of the CO2 through a pressure regulator into that pilot control cabinet, which controls a pneumatic timer, and that gives an added delay before a pneumatic valve is opened on the discharge line. Also, there's a noderizer on the discharge pipework, and as the agent discharges, it gives the CO2 a smell, so that, you know, people that would be in the room would have every opportunity to vacate it. The reason that CO2 was used in that instance was that the room couldn't be totally enclosed. These cat generators had cooling fans. They were about 8 foot in diameter, and the air intake from them couldn't be closed off. There was a vent on the opposite wall, and I insisted at the time that they use fire curtains there in an effort to seal up the room. But CO2 is the only agent that is permitted for use in areas that cannot be totally enclosed. Now, in that instance, I gave a training session to 20 engineers in Al Marai's factory in Saudi Arabia. When I came back a week later, the contractor that I did this system for contacted me and asked me for more information. And at that stage, I got all this equipment here from the suppliers in America. I set it up as a mock-up and did an hour-long video, because when the electrical engineer asked me to briefly go through the operation, I told them the best thing to do is to stay away with it, stay away from it. There's no doubt about it, these systems are dangerous. They're commonly used in marine applications, because the engine rooms in marine applications, you would need a lot of clean agent. CO2 is a lot cheaper. You can get CO2 cylinders filled in virtually any port in the world, and such systems are always manually controlled, so that if there is a fire in the engine room, the personnel on the ship can ascertain that there's no one in the engine room before they discharge the system manually. And the advantage about it in that instance is that it doesn't leave any residue. If you were to use powder, for example, to try and protect such a fire where the fuel is going to be an oil-based or hydraulic oil of some description, it is going to leave a pretty big mess that has to be cleaned up.
Well, on that point, Gerard, actually, we've had another question come in. Thank you so much for all of your questions. By the way, we've got another 5 or so minutes to get through as many of those as we can. But Gerard, you were talking about different materials there. In which instances are dry powder systems better than wet chemical systems?
They're two different agents and they have two different applications.
the dry powder is most commonly used for the protection of engine bays and generators such as the one here behind me. The reason it's used in that instance is that, again, a lot of these enclosures tend to have louvered vents in them. They have cooling fans. If you were to use a gaseous agent, the likelihood is that the gas, which is any of these gases which are heavier than air, would fall out on the road in the case of an engine bay without necessarily achieving a design concentration to knock down the fire. In the case of dry powder, it sticks to all hot surfaces, cutting off the oxygen, and it's oblivious really to the presence of the fans and any ventilation in the enclosure. The wet chemical agent is a different agent. It has a long chemical name and goes under different chemical names, but essentially it's like a liquefied salt. I don't know if you can actually see all of it here behind me. There is a cylinder there on the wall with the control cabinet and a backup of a stainless steel canopy. The wet chemical agent, it is discharged out through a different type of nozzle to that used for dry chemical. And when it is discharged, it creates what's called a soap-like saponification on top of the burning oil. This would be very much applicable to deep fat fryers. Deep fat fryers typically hold 45 liters of cooking oil, which for many years now tends to be vegetable oils. In the past, they used dry powder to protect such fire risks when they were using animal fats. But then when they switched from using animal fats to vegetable oils, the temperature of the fryers had to be increased. And then they found that the dry powder in itself had no cooling property to a large extent in the same way as wet chemical has. And there is a criteria there that in the event of a fire in a deep fat fryer, that you have to reduce the temperature of the burning oil by at least 30 degrees C within a very short period of time for the wet chemical to be effective. And the wet chemical is effective in that situation, whereas dry powder wouldn't be to the same extent. Also, the wet chemical systems are designed in such a way that the agent is discharged as like a mist from nozzles that differ for the various appliances, the canopy overhead, the plenum within the canopy, and also the exhausts. And they're designed in such a way that when it does discharge, that it doesn't splash onto adjoining areas. Like, for example, if you had personnel in a kitchen, you wouldn't want this agent discharging on burning oil, with the result that it might actually blow the burning oil on top of, in the opposite direction, on top of someone. And, you know, for that reason, this wet chemical is specifically designed for use in commercial kitchens and doesn't have really any other applications.
Right, Gerard, we've had another question come in. We're going to have to nail this one in about 45 seconds flat, I'm afraid, but I want to try and get to it. Is room integrity test for clean agents similar to a leak test? Thank you for your question.
Yes, it is. You need to do an integrity test on the room to ensure that when the clean agent discharges, that the room will have the capacity to hold the agent at its design concentration for 10 minutes after the discharge. Commonly, a common application is 7% design concentration. There's a door blower machine here used like the one behind me, and that is used to pressurize and depressurize the room. The readings taken from a digital manometer are fed into software applicable to the agent being used, and that software will actually show you a graph showing you the level at which the
Right.
agent will be after 10 minutes. And the criteria is that if you're trying to protect cabinets inside in the room, that the agent should still be above the top of the cabinet, or highest risk within the room after 10
Right.
minutes. If it has fallen below that level, it's a fail, and you have to try and seal up the room.
Gerard, thank you so much for all of your responses to our questions. Thank you for all of your questions as well. We've got through so much in the last 10 or 15 minutes or so, but we are out of time. Very, very quickly, where should people go if they want to find out more about what you're doing at Rottguard, Gerard?
They can go to our website at rottguard.ie, and there's 2 T's in that, and the phone numbers and the email addresses are there. And
Fantastic.
we'd be happy to answer any questions or queries people would have.
Good stuff. Thank you very much indeed, Gerard. Yeah, terrific stuff. Our FIREX Tech Talks continue, and they're continuing right now, where we're hearing from CTEC talking about their evac alert product, and we will be talking with the team from CTEC straight afterwards. I will see you there. Gerard, thanks again, my friend.